Okay, here we've got a question with some data given, and the first thing we have to do is set up a confidence interval. Now at S2 you've got two recipes for confidence intervals. One uses Z and the other uses T. You need to get straight the difference between those. In general, Z is when you know the population standard deviation, and you use T when the standard deviation you're using has been estimated from a sample, especially if it's a small sample. So first thing to do is to make the decision, is it Z or is it T? Make that decision now, pause the video, because the next thing we're going to say will give the game away. Okay, we haven't got the population standard deviation anywhere in sight. We have got a sample of size 10, and we're going to have to get values of x bar and standard deviation s from this data. So we're definitely using T. In order to get your x bar, that should be easy. You've got the sum of the v's, and to get your s, you'll go via s squared. This question shows you do need to have memorized your S1 formulas for the sample variance, because just you haven't got the raw values to put into your calculator. So luckily this time the version of s squared you need is actually in your formula book. You may not realise that it's on page 12 of your formula book. You've got one version of the s squared calculation. It does use a capital S squared, but don't let that put you off. It is the right formula. But if they'd given you sigma v squared instead of this thing, you'd have had to use the other version of the s squared formula. So if you haven't learned those yet, make sure you do. So you should be able to set yourself up an x bar and an s squared, so you'll get to an s, and then all you've got to do is plug those in to the formula, choose a suitable value for t, because it's a t situation, and you should get the right confidence interval. Now this bit, stating any assumption that you make, is probably the hardest mark to get. It's really worth getting to the bottom of this, because they are picky about things like this on S2. You need to know that when you're using T's, yes, you do it when you're using an estimated standard deviation, especially from a small sample, but the method is only appropriate if the parent distribution is normal. So you need to make that point, and that's going to be your assumption. But lots of candidates get no marks for the assumption because they just say, assume it's normal. You won't get credit for that because you have to say exactly what is normal. Now the general principle is the parent distribution is normal, but they like to see things in context. I'm not sure you'd always get the mark for saying the parent distribution is normal. You have to say the distribution of something is normal. So you have to go back and see what this data of V's relates to. And that's what it relates to. It relates to the speeds of his serves. So to be confident of getting the mark for the assumption, you have to make a comment about the distribution of John's service speeds. Then in part B, 1 mark for commenting on this claim. So you have to know what your confidence interval means. Your confidence interval means you have a pretty high degree of confidence that John's true mean is somewhere in the interval that you've calculated. So John is claiming he consistently serves at 130 miles an hour. Not just sometimes, consistently. So you've got to decide, is he claiming something about his mean service? If he is, then your confidence interval helps. If his claimed mean is within the confidence interval, you don't know whether he's telling the truth or not, but you've got no reason not to believe him. If his claimed serve isn't in the confidence interval you've worked out, you tend to disbelieve his claim. You can say it's unlikely to be true. So that's how you interpret part B for a mark. Hope that helps.